Assalamualaikum warahmatullahi wabarakatuh. Good afternoon from Indonesia, ladies and gentlemen. Welcome to International Virtual Lecture on Natural Resources Sustainability. My name is Nimal, and it's always good to see you here again on Day 2, Science Camp 2021. First and foremost, I'd like to welcome the Honorable Dean and Faculty of Mathematics and Natural Sciences UM and all the Vice Dean, the head of Office of International Affairs of MIPA UM with all the team, and also all the participants of today's event. And ladies and gentlemen, without a further ado, let's start our first agenda that will be the lecture from Dr. Vivi Novianti, MSI from Universitas Negeri Malang, and followed by the last lecture of today's event, which is the lecture from Professor Dr. Rerum Naturalium Jeren Albers from Aachen University of Applied Sciences, Germany. And to smoothen today's lecture, we are pleased to welcome our moderator today, Mr. Wira Eka Putra, SSI MNet SC. For Mr. Wira, the time is yours.
Okay, thank you very much, Miss MC, Miss Niamey, for giving me the control of this program. So firstly, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon from Malang. Hope you are doing well, everyone. So my name is Wira Eka Putra. Will be a moderator for this really nice agenda, the second day of Science Camp. So today we have two really interesting topics with two amazing speakers. So first, let's come up with the first section. It will be delivered by Dr. Pipino Pianti, which the title, Mining Environment Revitalizations. Okay, when you are talking about environment, actually it's kind of hot topic nowadays and global. So it will be lucky for you if Dr. Pipino Pianti share the behind of the research, of course, what she have been done and etc. related to the mining environments revitalizations. And for sure, now we are going to invite Dr. Pipi for give her lectures. But before that, I will read the curriculum vitae of Dr. Pipi Nopianti. So maybe operator, you can help me to show, yes, the CP of Dr. Pipi Nopianti. So I will make it short. She gained a doctoral degree at Institute Technology Bandung or ITB in 2013. And of course, for her career, she started 2015 as academic staff in Biology Department, Faculty of Mathematics and Natural Sciences, Universitas Negeri Malang. And on 2017 till 2020, she became chairman of Green Campus, Universitas Negeri Malang. And for sure, she has done a great number of publications, especially in environmental revitalization. So together with a warm welcome to Dr. Pipi Novianti, the time and place is yours.
Okay, that's a lovely introduction. Thank you very much for that, Pak Wira. Good afternoon, everyone. I'm Vivi, and today I want to talk about the mining environment revitalization. I will share screen of the PPT today. Okay. Sudah tampak? Okay. Okay. So mining environment revitalization. And I take coal here as cases. Okay, yeah. So I take coal as my cases here, just a cases here because I did my research here since 2007 until now. So Indonesian coal reserve is about 21.1 billion tons. And its make coal and mining in Indonesia is a major industry that contribute 4% to the country gross domestic products. And also it makes Indonesia is the fourth largest coal producer in the world after China, India, and USA. And this is the map of distribution of Indonesian coal reserve. It is located in Papua, Sulawesi, Kalimantan. This is where I did my research here. And then this is Sumatra and Java. So now we see how important coal for us. Coal is one of the most important sources of energy for the world, which is used to fuel electricity generation by almost 40% worldwide. The main fuel for steel production also using coal. Alumina processing centers, paper mills, chemicals, and even pharmaceutical industries also using coal for the fuel. And there are also coal byproducts, including soap, aspirin, solvent, dyes, plastic, and fiber. And as you see from this figure, yeah, almost these things we use, and it's using coal as the electricity or maybe the byproduct of the coal. Okay, now we see how coal is mined. Yeah, 95% coal mining in Indonesia using open pit method. What is open pit? Open pit means an excavation, or we cut made at the surface of the ground for the purpose of extracting the coal here. Yeah, and this is the step of the open pit. First is land clearing. It's quite a short time to doing this, comparing how this plant become a tree. It takes times. They use dozer for land clearing after it's already clear, and then they remove the topsoil. They save it to certain area. Yeah, we call it as topsoil bank. They will use it when they will reclaim the area. After that, when it's already clear, topsoil already safe in certain places, they do drilling for put the explosive materials, and then they do the blasting. What for? For destroy this overburden. What is overburden? All mine tailing from the coal, and all the reject materials. Yeah, and in Kalimantan, overburden is in the form of sedimentary rock. It contains of sandstone and clay stone. When they do blasting here, yeah, and then it will be easier for excavator, this truck, yeah, to reach the coal, and then the overburden will put in waste dump disposal here. That's why open cast mining operation involve huge quantities of overburden removal. Yeah. And of course, there's consequence of the open cast or open pit mining. Yeah. What are they? By its very nature, open cast mining degrades large areas. Yeah, not just within the mine area here, but also through the tipping of large amount of overburden on the surrounding area. This is the figure. This one is the overburden. Yeah, and we can see here is it looks like a hill, a big hill. Oke, gimana nih? Sudah, oke. Sorry.
Okay, Dr. Pipi, it's okay.
Okay, I will continue. This is not stable internet. Okay, so this one is the overburden, yeah, and it's characterized by the poor nutrient, and the pH is very low. It's about 2 to 5. That's why the trace metal is high. The concentration of the trace metal is high because of the low pH here, and also it contains of boulders, cobblestones, yeah, as the media. So if this overburden is not replicated quickly, there can be large-scale erosion with detrimental impacts on local water resources, sedimentation in river, and etc. Moreover, the consequences of the open pit is a massive land clearance, yeah, for coal mining in Indonesia as an additional pressure on primary forests, which are already under threat from logging for both timber and conversion to palm oil plantation. For the information, the first major or the main factor of the deforestation in Indonesia because of the conversion forest to palm oil plantation. This is the main factors, following by the logging and conversion to agriculture. So how large areas impacted by the open cast mining in Indonesia is approximately 7 million hectares land impacted. Maybe we think that it is quite small comparing to the total land in Indonesia is about 1.3% of the Earth's surface. We talk about land impacted means that forest, because most mining, coal mining, happened in forests. And forest is very important. I will tell you later about how important a forest is. Okay, and in 1950, Indonesia had forests of approximately 162 million hectares, and that's why at that time Indonesia known as the lung of the world, to show that it's important. The forest in Indonesia is important for the world, but we just need 50 years to this forest have shrunk by about 40%. Only 50 years, 40%. The forest is lost, yeah, so that its position, the Indonesia rate destruction in the world is #1. You can see here, this is Kalimantan Islands. In 1950, this is green, which is mean that it's forest. But 50 years later, in 2000, we can see here, yeah, and getting worse in 2020, maybe only left 40% left here, yeah. And actually, we have regulation. The Indonesian government make regulation to protect environment. The first one, the principal one, is the law of the Republic of Indonesia, number 32, year 2009, concerning protection and management environment. And special for the mining, there is regulation of the Ministry of Energy and Mineral Resources. Number 18 is about reclamation and mine closing, and so many others, which is we have regulation of it. That's why each holder of a mining business license, just said as a mining company, they have to require to submit a reclamation plan and a post-mining plan at the time of submitting the application. So they have think far away before the application, before the mining operation carry out. Yeah, and the mining company also have the mandatory submit reclamation guarantee funds to the government to make sure that the mining company will reclaim the area after they finish their operation, the mining operation. And reclamation is actually a part of the revitalization or type of revitalization. What is revitalization? Revitalization is an attempt to revitalize an area that was once vital in life but suffered from setback and degradation. And this is the stages of reclamation that's stated in the regulation Indonesian government. Yeah, first is disposal and surface arrangement. This is overburden, and then hauling topsoil, and then spreading topsoil, then land arrangement. After that, construction of drainage, and think of okay. Saya keluar dari saya catering soalnya.
Dr. Pipi?
Yes.
Can you hear
yes.
me? Okay.
Yes,
Maybe
I can hear you.
connection. Okay. So maybe you can start with the construction of drainage.
Okay. Thank you, Pak Wira. So after that, construction of drainage and erosion control, and then planting cover crops and pioneer plan, and then local plant insertion and maintenance and monitoring. Yeah, this is a step of reclamation. And this is the example of mining reclamation that carried out by PT Newmont in Nusa Tenggara Barat. This is gold mining company, and they already close mining, and they have to reclaim the area. And the step here is the same as the previous slide, as I shown before. And what makes different here that this company using quite big or much topsoil, 2.75 meters, where most mining company mostly using only 60 centimeters only. And this is hydroseeding, to avoid the soil erosion, and then planting. And this is the revegetation area that's already dense with the tree canopy. And the following are the other example of mine reclamation. This is limestone mine reclamation in Tuban, East Java. They're planting with certain species. Seems that it is Anthocephalus macrophyllus because of this large leaf. And then this is coal mine reclamation in Jambi. The big hole they make 40 meters deep hole, they make as a tourist attraction. The same thing happened in Sangatta, is Kalimantan, coal mine reclamation. They changed it to Telaga Batu Arang or Batu Arang Lake for the ecotourism. And it's also happened in tin mine reclamation in Bangka Belitung. They changed it the whole as the Kampung Reclamation Bangka. Okay, so is there another option beside the reclamation? Yes, we have. What is that? Restoration and rehabilitation. What we just discussed just now is reclamation, which is mean replacement. To be what is depend on the agreement between the government and the mining company. If they agree to make the ecotourism tourist attraction, then it changed to based on this agreement. Okay. Myself, I suggest to do the restoration. Why? Okay. I give you the illustration here. If this is original ecosystem, just say that it is forest, and then our activities degrade this ecosystem to this level. Just say that lowest level here. Restoration means bring back to the original ecosystem or original state. And rehabilitation is almost the same with restoration, but it's not 100% fully back to the original state. Because of many reasons. For example, loss of biodiversity. And why I suggest restoration? Because forests give many ecosystem services that cannot replace by the ponds, by the lake, by the whatever it is that doing by many companies right now. Even though we cannot blame them because the regulation is asking to be reclaimed the area. But we have another option actually, restoration. Forests give many ecosystem services to us. And beside that, there is ethics and sustainability. We stated that if we cannot give a better situation or condition or ecosystem to our next generation, at least the future generation, feel the same as us. So if now we can see orang utan, we can see rangkong bird, we can feel and see the dance of forest like this. So at least our future generation also feel the same as us. That's the ethic of sustainability. That's why a forest is very important. And what is ecosystem services? This is interaction both between organisms and with their physical habitat. And this interaction result in ecological process that interact at different scale to deliver ecosystem services or natural capital that have value people. So I think it is weird when we get something benefit for us, human people, but we destroy it. Something weird, right? Okay, sudah. Okay, sorry, I will continue again. So this is the services given by the ecosystem, they are including a forest. They are supporting, provisioning, regulating, and cultural. And there is constituent from here, from these boxes. I will tell you the example, just a few of them. For example, nutrient cycling. Have you imagined when you eat, just say a fruit, banana or mango, and then you just throw away the peel and a few days ago, a few days later, you didn't see it, where it goes. Yeah, who worked for you? See, and where it goes. Yeah, and who worked for you is the decomposer. Who are they? They are the microbe and soil organism. Yeah. So actually, there's no waste in this earth except the plastic because of human made it. Yeah, that's what supporting what the service is given by the ecosystem. The another example is of fresh water. Yeah, fresh water. We get it freely. Yeah, even though we have to be careful because of we destroy our ecosystem. Now we have to pay it. Yeah, in Indonesia, for example, for liter of mineral water, we have to pay it about 7,000 or 8,000 rupiahs, yes, or a $50. Quite expensive for something free before. Yeah, because of we destroy. And the last one is a water purification. Have you imagined why your aquifer is always clean? Who did it for you? The tree is the answer. Tree, the root of tree doing filter the particles, so you always have clean water in your aquifer. Yeah, that's why tree forest is very important. And this is how we are cut ecosystem services. Yeah, so many human activities starting from disrupt, impair, or re-engineering ecosystems every day, including pesticide, fertilizer, animal waste, pollution of land, water, and air resources, introduction of non-native species, overharvesting, destruction of wetlands, erosion of soil, deforestation, and urban sprawl. This is just a few of them. Yeah, and I will give you the real fact, what happened when we destroy our environment, just few of them. The first one is when we drain the wetlands. It's happened in Mississippi River in USA. Yeah, they change it, become property. They make building for house, for office building, and also change it to agriculture. So they drain the wetlands. And what happened next? Since 1993, yeah, this area always flood happen every year. And this has resulted in property damages estimated at 12 million US dollar every year. Yeah, because of wetland were gone. Wetland, one of the function of the wetland is to absorb water. That's why never happened flood before. But when we drain it, then no absorption. Okay. The next example of ecosystem services is over 100,000 different animal species, yeah, including bats, bees, flies, moths, beetles, birds, and butterflies. They provide okay, they provide free pollination services, yeah, where 1/3 of human food come from plant pollinated by these wild pollinators. How much the price? If we have to count the price, in the US alone, it's about 4 to 6 billion per year. However, because of we use pesticide every time, and most of them are getting decreased the number and also extinct. And some of the animals, some of the insect getting resistant because of the pesticide. Okay. Okay. Okay, the last one is come from my country, Indonesia. Unfortunately, introduction of non-native species. This is happened in Baluran National Park. Okay, Baluran National Park is known for the vast savanna. That's why it's famous with the name of Africa van Java, which is mean that Africa in Java. Yeah, because of the vast savanna here. In the late of 1960s, our government introduced acacia. Okay, okay. This is the tree of the Acacia nilotica, the fruit and the flower, and it's also characterized by the spine. Yeah. What for? The Indonesian government introduced this non-native species to prevent fire, because savanna is often frequently burning, especially in dry season. That's why we plant it to prevent the fire to the adjacent thick forest. Yeah. Unfortunately, this Acacia nilotica is very aggressive. It's very adaptive, grow fastly, and finally it infect the savanna very fast. Yeah, this is the data given in 2013. The area of Beckel savanna in hectare is 186 hectares, and 1 year later, 2014, it just only left 101 hectares, which is mean that only 1 year this Acacia nilotica invaded 85 hectares of savanna. Maybe we think it's fine, ma'am, because we change grass become the tree. No, it's not okay because it's not because it's non-native species, and savanna is the habitat of many local big mammal in Baluran. Yeah, they do the grazing and activities there, and when it's decreased means it threatened them. Okay, so we back to the revitalization. So is it possible, ma'am, to do the restoration back to the original state? I say yes, it's very possible. How? That's the question. Yeah, so we learn how nature repair themselves when get disturbances. Yeah, in ecology, there's a concept theory of succession. When there is disturbance, nature will fix it, yeah, by himself, but it takes time. Yeah, if we start from the bare rock, just in case like in overburden, yeah, it will take time here, hundreds of years. And just take example of Krakatau, Mountain Krakatau, which is erupted in 1883. Yeah, which is mean it's already 133 years ago. But until now, yeah, it's not reached the climax community yet. Yeah, and the scientists estimated it takes about 300 years to reach the climax community. Okay. And what is succession? Succession is directional changes in plant community after severe disturbance. If that no leaf soil layer intact, we call primary succession, and it takes time, much time. But if the disturbance still give the soil layer intact, we call secondary succession, and it is the time is not as long as the primary succession. Okay. And I use these tools, I use this concept as tools to manipulate the restoration here, the succession here. Yeah, this is my 1 hectare experimental area in Kalimantan. As you see here, there's no soil layer intact here. This is overburden. As I said previously, this is low pH, high elevated concentration of trace metal. This is boulder stone, yeah, and poor nutrient. And as you see this year, yeah, in this figure 2011, I starting planting this plant. And this is the area of the mining company. They use reclamation stages as explained before. They use soil here. Okay. And this is to show how hard the medium for plant medium here, because it's stone. I cannot use, hoe, or in Bahasa is cangkul, because the handle always broke. That's why we use crowbars, yeah, to make only the plant hole here. Okay, and this is the result of primary succession manipulation after 4 and 19 Okay. So this is the result of primary succession manipulation after 4 and 19 months after treatment. So what I did is I learned from the succession, I tried to cut the step to speed the time. And I use the ecological engineering approach where the organism as my engineer, not human. So I have to know what is plant should be planted and who other organism that I can be used for my engineer. And this is the result. Yeah, it's not that I think yeah, this is getting green here and greener every time. And this is 7 years after treatment. So I back in 2018, yeah, about 3 years ago, and this the situation. And it's almost the same with the reclamation area, but they use very high cost because they have to put fertilizer and soil and also high maintenance. And this is monoculture because the dominated plant is the Acacia mangium. Yeah, well, in this area, I've planted many species here. Okay, and if we make closer the area, as you see here, is dominated by shrub or bushes here. Yeah, it's almost I cannot enter this area. We have to open it to for our track. Yeah, and almost no space available, full of the shrub here. And unfortunately, yeah, this shrub is non-native species. Yeah, it's badly, sadly, because I expected the local species come here, but in 7 years later, it's dominated by non-native species, namely is Chromolina odorata. Yeah. However, what is encouraging me, I still find the local species present in my area. Yeah, this is one example of the local species. And this is also the local one. And this one. Even though when I come there 7 years later after the treatment, they just in the form of sapling and seedling. See, this is a pencil, not higher than my pencil, but hopefully I'm very hope that they're able to grow well and someday they will dominate the area. They can replace the non-native species. Yeah. And what make me happy too is when I try to measure the diameter of the plant the tree here that I planted 7 years ago, I found this beautiful creature. Yeah, the name is Chrysopelia pelias. This is the red flying snakes because the snake can move from tree to tree by hovering in the air. Yeah, and it is found in Southeast Asia. So it's not a native. This is one of the local in Southeast Asia, including Indonesia. And the snake is found in the interior of rainforest and far from human settlements. So it's almost rare to us to able to see these snakes. And I'm the lucky one. Yeah, because I can see this beautiful snake. And this is active during the day. The main prey are lizard, geckos, and frogs. And yes, I found many frog, geckos in the area. It means that the food web is running in the area. I found also many snakes in the ground. Yeah, and so far I found many birds who put their eggs in the nest in the shrub. Yeah, so when we planting, especially with diverse plant, means that we create habitat. Yeah, so I just want to say that everything that we did, it will be impacted to our environment. We can decide is it positive or negative impact that we given to the environment, but still sustainability ethics should be keep in all to all human because we have next generation to be able to feel what we felt right now. Okay, I think that's my last slide. Yeah, and which just mean that my last presentation. I give it back to Pak Wira as the moderator. Thank you very much.
Okay, thank you very much, Dr. Pipi. Maybe we can give a big applause, yes, for the insightful lectures. So actually, it's really interesting what Dr. Pipi present to us. Actually, I learned valuable lessons today. So love your environment. So it takes a long time to recover our environment. So, okay, guys, I invite you to give such a question. So maybe you can drop it in the chat box or you can raise your hand. Okay, so waiting for a question. Maybe Dr. Pipi, I have one question. So
Yes,
actually, I really wonder about how effective and the success rate of environmental revitalizations. So what is the crucial indicators?
Okay, in my case, when I very expected to do the restoration, one of my success parameters is if my area in 1 hectare area is dominated by Dipterocarpaceae. Dipterocarpaceae is the family plant that is belong to Kalimantan. Kalimantan is characterized by the Dipterocarpaceae. This is a big tree with a big diameter. That's one of my parameters, very important. So if it is dominated by this plant, this family plants, means that I can I can publish new article that restoration could be happen. When many people think that it's possible to bring back something that lost and then we bring back, right? But yeah, it takes time. And my estimated, at least I need about 15 to 20 years later to see whether it is success or not. The seedling, the sapling that I saw now, the local species, hopefully 50 years later, there will be a big tree and will dominate it.
Okay, okay, I see. Thank you very much, Dr. Pipi. Dr. Pipi, I think one participant have a question. So Ranum, are you there? So do you want to directly ask Dr. Pipi? Ranum from UNESA.
Yes, here I am. Can you hear my voice?
Yes, for sure.
Okay. Thanks for the time. I want to ask you something. Coal mining and other human beings that can cause negative environment, such as extinction of endemic species. So the restoration may get back the plants, but how we can get back the animal? Is it impossible to get them back totally because of by the coal mining and other human being may can get no species in long time to get back. Thanks for the time.
Okay,
thank you. Thank you, Ms. Ranum Melinda from UNESA. What a interesting questions. Yes, many animal extinct because of we lost our forest. Of course, we cannot bring back them because it's already lost. Yeah, but however, by create the diversity plan there, especially the Dipterocarpaceae, hopefully that the present organism right now is still exists and could be there will create another local organism, which is it takes time, but at least we conserve the present animal now. So we cannot bring back the extinct one, but we can keep that still exists right now.
Okay, Ranum, are you clear with that answer? So do you have any feedback?
That's all. That's really clear. Thanks for the answer.
Okay, thank you very much, Dr. Pipi, for your answer. So, okay, I still invite the participant to drop your questions in the chat box. Okay, Dr. Pipi, I also have another question. It's okay for me to
It's
give a
fine.
question. Okay,
Yeah, it's fine.
so actually, I also wonder about the future directions of this kind of research, the environment revitalizations. So, how you see this in the future?
Loh. Okay, Pak Wira, I will tell you a little bit story about how I did the restoration. Yeah, this is actually starting when I did my research for my PhD in 2007, when many people think that it's possible to planting the stone. Yeah, because the mining company is pushed by the government, by the regulation, they have to grow a plant, a tree. Yeah, well, we know in ecology, if we start from the bedrock, it means that we start with the grass first and then the shrub and so on. Yeah, it takes time. That's many people say that it's impossible because dissertation only 4 to 5 years. Yeah, but and then I tried to contact the people who did restoration in another country, and they said that just do it, Vivi. It's possible. We just different. I did it in temperate, and you can do it in tropic. So many people in here in Indonesia at that time is very pessimistic, but because I learned about ecology, about succession, and I get supporting from my colleague, yeah, who did it restoration. Then I did it, and that they encourage me with saying that do it now. I know that in sorry to say this in developing country environment is not the main point, right? It's about economic. But when the environment getting worse, they will looking for you. So just keep in this field, just wait the time. Every people do the degrade area, degradation, yeah, the degradation area, and yeah, we will need it. So I'm very optimistic. It will be needed by all of us. This science, this knowledge will be needed by all of us. I think that's Pak Wira.
Okay, thank you very much for your explanation, Dr. Ricky.
Yeah.
So I think we have another question from Chai. Hello, Chai. Are you there?
Yes.
Yes. Maybe you can
Okay.
ask directly to Dr. PP. Welcome.
I just want to know, after the restoration, how about the weather change? Is it get better, fresher air, or do you have more rain like that?
Okay,
Thank
I
you.
got it. Okay, thank you, Chai, for the questions. May I answer the question, Pak Wira?
Okay, for sure. Yes.
Okay, so the weather, yeah, of course, yeah. When I first time uh, visit my area for doing the restoration, it's very dry. Almost I cannot even find animal. I just met the ant and the okay, I just only find that two animal, ant and spider, because it's very hot. When I measure the temperature of overburden is about 35 to 40 degrees Celsius. It's very hot. Yeah. But of course now with the many plant there, so when I go there in 2018 for the measurement observation, uh, is more is better. Yeah, the temperature is for the local, yeah, for the local temperature, it's not too hot. It's not too hot. Yeah, even it's still in Kalimantan temperature still about 30 degrees Celsius. But with the plant, of course, everything is better. Yeah. So I think that's the answer for the
Okay.
weather. Yeah.
Okay. Chai, do you still there?
Yeah,
Do you
yeah.
have any feedback?
Thank you. Yeah, it's
You're
very
welcome.
clear.
Okay, okay,
Yeah, thank you very much.
okay. So, Dr. Pipi, maybe this is the last question because the time from Nicolau Alpes. Nicolau Alpes, are you there? Where are you from?
Yes, I'm here. I'm from Timor-Leste.
Oh, amazing. So you can directly ask your question to Dr. Pipi.
Okay. I'm a little bit confused about. So I have one question here. So what kind of method did you think is better using for the restoration?
Really?
What kind of method did you think is better using for restoration?
Okay. Thank you, Nicolu Alves from Timor-Leste. Hopefully that I can go there. Yeah, actually, this last year I will go to Timor-Leste for the join the supervision, something like that, but because of the pandemic, it postponed. Okay, what kind of method is better using for restoration? Yeah, I use succession as my tools. Yeah, succession. So as I shown in my slide, yeah, succession is actually nature can do it. Yeah, but it takes time. That's why I learned each process of the primary succession, and I try to find where I can cut the step, so it not takes much time. Yeah, I trying to learn how nature work for fix itself. Then I try to mimic how nature works. This is ecological engineering. And from I studied that for 1 year. I tried to analyze, yeah, what kind of species plant that I will use as my pioneer, my follower, my next step. I studied them well for 1 year. Yeah, and which is mean that I mimic how nature fix themselves. Yeah, after that, I try to trigger, I give a treatment to faster, yeah, to give a medium for the plant that we call as ecological engineering. What I give, yeah, you can, one of my paper mentioned that the key in restoration in Kalimantan in tropical forest that make different with the temperate is the humid, yeah, it's a humidity. So water is very important. Yeah, humidity is very important. And the second one I use is the local plant of Kalimantan. Why? Because it's proven they are have a good adaptation in Kalimantan. When many people reclaim with the invasive, such as Acacia mangium, they also use hydroseeding with the invasive one, Centrosoma pubescens. We buy it from Australia. Can you imagine? We buy it from Australia and they are invasive, even though it's good in for minimize the soil erosion. But later I know that it is invasive. Most of the my pioneer plant die because of Centrosoma is cover up the local and cannot get the sun. Yeah. So the better tools is using succession, ecological engineering. Use our local species for your engineer. That's why we have to know who are they, yeah, to do the restoration. If not, we will back to the reclamation again when it's very high cost. Yeah, we have to put soil there, and then because of the low pH, we have to bring something to make the pH getting normal, 6 to 7, and then we buy the hydroseeding from Australia, and we planting only one species, Acacia mangium. Something is not worth it. Yeah, because again, forest, and then we plant it with one species. Yeah. Okay. I think I hope that it answer your questions, Nicolau. Thank you.
Yes. Thank you, Dr.
Yeah,
Pipi.
thank you.
Okay, I
You're
think it's
welcome.
clear, right, Alpes? Okay, so actually we already time's up, but we have one more question. Do you think you will answer, Dr. Vicky?
Yes, sure.
Okay, okay. I don't know how to read this name because I think it's from Thailand, B609. Yeah, maybe. Are you there?
Yeah, yeah, I'm there. Can
Okay,
you hear me,
so
Cherry?
okay, so you can ask Dr. PP directly. So maybe you can
Thanks.
introduce yourself so everyone know
Hi,
your name.
everyone.
Hi.
Thanks so much. Hi, everyone. I'm from Thailand. My name is Satwat Pedit. My nickname is Pon.
Tom.
I'm
Okay.
studying at the Suratnari Technology University.
Okay,
I'm
SGT.
yeah. I'm at a hospital right now. Maybe it will be loud around here. About my question, yeah, feel we can bring back all animal, right? Feel the professor say about that. Feel we can breed a native animal and bring back to the wild. Is that a good solution to fix this problem? Feel we can bring we can't bring all the native animal back. Sorry, we can bring all the native animal back. The breeding is a good solution for this problem. Yeah.
Okay, thank you very much, Tom, right? Sorry if I'm wrong mention your name. Okay, thank you for the questions. It's a good question. Breeding will the good solution to solve this problem. Yeah, of course, in one, one solution cannot give answer all the problems. We have to work together. Yeah, I work for the, to bring back the structure of the vegetation, and according to my experiment, yeah, some of animals come to the area, and for to increase their number, of course, we have to do conservation to these animals, such as in breeding, and then, yeah, we can bring from the somewhere still local. For example, from the zoo, maybe they already full, they can put back to the uh, real habitat. The problem is nowadays is the nature, their habitats, natural habitats is broken. Yeah, everywhere is damaged, degraded, so we cannot bring them back. That's the problem. And sometimes they have to adapt, do the adaptation quite long, because the area where they need to do the grazing or grazing or their activities is now much decreased, yeah, because of the deforestation. Such as, I give you example of elephant. Yeah, we think that maybe one national park is enough for this animal elephant. Yeah, but the result, the data show that for the elephant able to breeding, they need certain a very big area. If only they able to just stay alive is fine, but to be breeding they need more. So it is important to create habitat for this kind of animals. Yeah, I think that my answer, Pak Wira. I hope that answering the question.
Okay, thank you very much, Dr. PP. Maybe Tom, do you have any feedback?
Uh, 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 Sorry, I'm at the hospital right now.
Oh, okay, okay, okay.
Okay, it's fine.
For about my question, yeah, Peter, I hear the professor say that we can breed them back, right? But feel we had a big problem in Thailand about the breeding the native species back to the forest. The government said that people breeding is too much. If you heard the environment, feel that some other species is too much. Example about the snake in Thailand. I do about research about the cobra in Thailand. We breeding and get them back to the wild, but we had a big problem about the people in the local area. Yeah, feel we breeding it overleash. if you eat too much rat in the right field, and it will hurt the environment. Yeah, it's a big problem right now. People breathing it too much. And people, what do you think about the breathing solution to fix this environment? Yeah.
Yes, okay, I got it, Pak Wira. Thank you. So it's about the breeding when is the number is increased and then it's become treat the local area. Yeah, it's happened also, Nicole, in the Indonesia, but it's because of breeding, because the cobra in my area, yeah, in Java, they lost their habitat. Yeah, nowadays in my country, a field price is building for the property, especially for housing, and they lost their habitat and they go to the, to the, what is it, to our house. Yeah, I feel that too. My house, two cobra coming to my houses, and hello.
Hello,
Okay.
hello. Okay.
Okay, hold it. Sorry. And my neighbor also the same because their habitat is destruct. Yeah. And unfortunately, they kill the cobra. Always my question is, what's wrong with the cobra? It's not. This cobra fault. Yeah. They just going to our house because of they're looking for rats, not for us humans. Okay. So about the breeding, for the breeding, of course, we breed for them, for the animals that they are decreased. Yeah, we have to breed them to increase their number. But for those who already increased, I think we have many things to concern. Yeah, for the extinct one, for the decreased one, that's why we have to breed. Tom.
Tom.
Yeah, yes, Tom. So if we already bring back to the area and then they still come, we have to think what's wrong, because actually they're not looking for us. Yeah, maybe in the habitat they cannot find their food. Yeah, again, cobra and anything else, elephant also is become in problem in Indonesia because they lost habitat. Therefore the solution is give their habitats. Yeah, I think that's Pak Wira.
Okay, thank you, Dr. Pipi. Tom, I think it's clear, right?
Yeah, it's already clear.
Okay, okay. Thank you, Tom, for your questions. Dr. Pipi and everyone, I think our time is up actually. We have 3 minutes more. Maybe Dr. Pipi can give like a conclusion remarks for closing our first talk today.
Yeah, my closing statement is we as a human, yeah, we as a part of the ecosystem, part of the environment. We're not apart from, yeah, but we are a part of. If something happen with the environment, such as in forests, and then we get the impact, yeah, later, sooner or later, we will feel that. So never thinking that we are a part of, but we are a part of. We have to take care of the environment. And what happened nowadays is human activities always degrade the environment. Yeah. In Java in 2024, it was estimated by the scientists we will lose the clean water. So you can imagine the important thing in our life, water, will be like in Java. Yeah, and it can be accepted because many trees are gone nowadays. So please doing something that you can do for your environment, starting from the small thing. Bring tumbler, don't use plastic, minimize them. Okay, I believe that everyone from us responsible for the environment. Thank you very much, Pak Wira.
Thank you very much, Dr. Pipi. Such insightful lesson and wisdom, I think. So, give applause to our speaker, Dr. Pipi, for really great lecture. So, I thank you very much, Dr. Pipi, once again. I think we will go for the next sessions. But before we go to the next sessions, I will remind you all for the participants. So maybe you can fill out the survey for the session 3. So you can find out the links on the chat box. Okay. So now we are going for the next talk. It will be delivered by Professor Albert. So maybe I will check Prof. Albert. Hello, Prof. Albert, are you there? Okay, maybe operator can help me to find out Prof. Albert if he already in Zoom meeting. Okay, okay. Actually, for the second talk, the title of Prof. Elder's presentations it's about biofuel and green energy. When you are talking about the green energy or renewable energy, of course, you will include some aspect like environmental aspect, sustainability, or even the economic aspect. So I think in the next talks, Prof. Albert will talk pretty much about how to make a biofuel and to use the green energy as solutions for our environment. So before that, I will introduce you about the short CP about Professor Albert. So the full name is Jirion Albert. So from 1994 till now, as a professor of ecological chemistry at FH Aachen, University of Applied Science, Germany. So of course, till now also become Dean of Education in faculty. For the research interest, there are a lot of types such as air quality, multi-type mass spectrophotometry, atmospheric chemistry, polymer material, and etc. You can see on the slide. For the professional memberships, of course, there are Association of Germany Engineers, and the second, like the German Society of Mass Spectrophotometry, and etc. So maybe for the presentations, maybe operator can help me to play the recording video of Professor Albers. Oh, Prof. Albers, are you there? Can you hear me?
Yes, yes,
Okay.
I can hear you very clearly. I'm here.
Oh, yes,
Can you
yes,
hear
yes,
me?
yes. Yes, for sure.
Oh,
How are
it's
you?
very, yeah, I'm very fine.
Okay.
Yeah.
So I think
very,
it's still in
yeah.
the morning, right? In the German.
Yeah, it's now 9 o'clock in the morning.
Okay, okay, okay.
Very fine time for me, and I'm very happy to be invited into your event and in the camp and to be a lecturer here now.
Thank you. So of course, we also thanks you for your time to give us lecture and insight. So Prof. Albers, I want to ask, do you want to direct your lectures directly or using recorded video that you sent to us?
I can I can try to do directly because I think it's better.
Okay, okay. Thank you, Prof. Albers. The time and place is yours.
Okay. Now I must look for my I'm sorry, I didn't. Okay.
Okay.
So I hope it is now starting.
Still loading, I think. Yes.
Yeah.
Soon.
Cannot start it now.
maybe you should double click, Prof.
Yeah, I have a screen and I cannot. Why is not possible?
Oh, really?
Maybe I can. I
Okay.
can try from this screen. Is this okay?
Okay, it's okay. So maybe the operator in Malang University will help you to show the PowerPoint. It's okay for you?
I have the presentation, but there's a screen and I cannot click on the. What? No, it's not
Or
possible.
maybe you should stop sharing mode, so you try again.
Okay, yeah, I stopped
Okay.
sharing. Yeah. Yeah.
I think it's
Yeah, there is a line and I cannot click on starting presentation.
Oh, I
This
see.
is a problem. I cannot stop the line here in the top of my screen. So I cannot click on starting presentation.
Starting presentation.
I cannot click on starting presentation. Okay. I think is it okay if I talk in this form?
Okay, I think so. Maybe the operator in Malang University will share your PowerPoint. It's okay?
Yes, please wait a minute.
Okay.
Okay.
Okay, operator, please, maybe you can share the PowerPoint from Prof. Albert. Okay, can you see the PowerPoint, Prof. Albert?
Yeah, I can see.
Okay. Thank you, operator. Please, Prof. Albert, your time.
Thank you. Yeah, thank you very much for your invitation. My topic is biofuel then green energy. In detail, we are talking about biogas. Next slide, please. Or can I? Yeah. Let me first introduce our institution. It's called Novum Energy. It's an institution depending to the University of Applied Sciences in Aachen, and it's an institution of the Faculty of Energy and Technology. But in this institution, scientists from different faculties work together, and Novum means, as seen below, sustainable economic development of ecological systems, and we are an institution who transfers scientific knowledge to industry and to practical use, and we have a lot of research and development projects. Next slide, please. Yeah, the topics I want to talk about, short introduction and background, main steps in biogas formation, potential substrates for biogas production, methods to pre-treat the raw materials, parameters which affect the biogas formation, and the most important, how to test organic residue materials for use in biogas plants. And we can look at an example, a case study about using sludge of paper and tissue industry to convert it into energy. And final conclusions. Next slide, please. Yeah, why we deal with biogas, I think it's obvious. We have the big problems with climate change, global problems, increasing energy demand, loss of biodiversity. We heard of it in the presentation before. The complete nature is affected by what the man do in worldwide, and change of climate. You see there's a picture. It's only 5 weeks ago in our region we had a very big disaster, a flood. Never seen something like that. For you in Indonesia it's very normal, but not in Central Europe, and 180 people died in our region. And it's connected with the climate change. And so we have a lot of things to do something against climate change. Next slide, please. Yeah, one reason is we have a gap of energy supply. If you calculate the energy demand for the next decades, we see that we have to care about new and renewable energies, because the energy supply from the classical energy is decreasing, but the demand is increasing. And we have energy prices which increase, and scarcity of fossil energy sources too. Next slide, please. Yeah. Let's have a look on sources of energy. We very well know the classical energy sources like fossil energies, oil, coal, gas, produced in Indonesia in a big amount, nuclear energy like uranium. And on the other hand, we have renewable energies. We have to look at a little intense in the next decades: sun, wind, water, geothermal energy, and biomass and biogas. I read now today in the newspaper in Indonesia, there's a big power plant for getting energy from sun in Batam on the sea. And it's a very fine example, and I was happy to see it. Next slide, please. Yeah, I want to talk a little more about biogas. What is biogas? Biogas is a natural gas which occurs from natural in a natural way, and the biogas has a complex composition, but the main components are methane and carbon dioxide. About half of the volume is methane and the other half is carbon dioxide, but we have in a smaller amount other gases like water, steam, nitrogen, oxygen, hydrogen sulfide, and hydrogen. The most interesting component is methane, because methane is the component which contains energy. About half of the biogas, as I said before. It's a colorless and odorless gas, and it's produced by methane producing archaea. And the heat value is about 10 kilowatt hours per cubic meter. Next slide, please. The specific role of biogas. If we look at renewable energies, different problems have to face. If we use wind and sun as source for energy, we have to concern that cannot be controlled, because we cannot control the weather. When there is no wind, we cannot produce energy from wind, and if there's no sun, we cannot produce energy from the sun. In Central Europe and in Germany in detail, we have a lot of wind energy plants and sun, and the number is increasing, but there's the problem: how can we give a continuous energy supply. How can we store the energy? And what can we do if the weather is not okay or not good for producing energy? And this is one of the main advantages of biogas, because biogas can be produced continuously in biogas plants. It's, as you see in the center of this slide. And the other advantage is you can store the energy, because you can store the gas and you can convert it into other forms of energy if you need to use. Next slide, please. Yeah, here you see a flow chart, a scheme of a typical power plant, about 1,000 or 2,000 cubic meter. The most important, the center of this plant is a fermenter where the biogas is formed by the biological processes. On the left side, we have the supply with substrate material from cattle breeding, but I will talk about that later. Fertilizers, which can be taken from the residue of the biogas process. And on the right side, what can we do with the biogas? We can clean up the gas processing, and we can give it into a gas distribution system. This is very normal in Central Europe and in Germany, that the households have gas for their heating. We in our house have gas for heating, and this plant in the house can use methane from fossil source or from biogas. It's the same. So this is a important advantage. You can convert it into biofuel for cars, or you can give the biogas to power station and produce electricity and heat. Next slide, please. Yeah, the main steps in biogas formation. Next slide, please. Yeah, there are 4 different stages to produce in the biogas formation. Very simplified here in this picture. You start with a substrate containing carbohydrates, proteins, lipids, and something like that. And the first step is the hydrolysis of these compounds. The complete progress is done by a complex community of microorganisms who work together depending on the conditions and on the material you use as substrate and the size of the plant and something like that. By the hydrolysis, fatty acids are formed, amino acids, sugars, alcohols, and so on. And the next phase is the so-called acidogenesis, because in this phase, volatile fatty acids are formed as fatty acids with short chains. And this is sometimes a critical step because the pH value decreases. And the next step is very important because acetic acid is formed. So it's called acetogenesis. And acetic acid is a key compound in the production of methane. In the acetogenesis, carbon dioxide and hydrogen are produced too. And the final step is the methagenesis, where methane and carbon dioxide are produced, and there are different ways depending on the microorganisms involved. There's an acetotrophic and a hydrogenotrophic way, but the result is the methane we want to produce. Next slide, please. Now, which substrates we can use for biogas production? Next slide, please. Next slide, please. Yeah, we can use to produce biogas in principle any organic substances, and there's a lot of variety of substrate material which can be used. For example, renewable materials from agriculture, corn, grass, sugar beets, wheat silage, and so on, which are produced to use it in biogas plants, but this is the competition to production of food. And this is a little in discussion. Then the next is waste from animals, from farming, slurry from cow or pig or chicken, fecal matter of chicken and something like that. So we have products as substrate which are existing in farming, and many plants use a mixed substrate, and we call it co-digestion plants to mix different materials from agriculture and farming. Next slide, please. Yeah, here you see some examples of waste material from food consumption, organic waste, bio waste, which if we go to the big market in Malang, we see something like that after marking closed. Green waste, kitchen waste, slaughterhouse waste, all this material could be used to produce biogas. In many cases, it's thrown away, and we have problems with waste disposal, but it could be used in biogas plants. Next slide, please. Yeah, the advantage of food waste is that it has high content of water, and this is good for the biogas fermentation process, and the composition in many cases is fine to produce biogas. Waste from food production is a little different. It's not waste from food, it's waste from food production. And we should have a look on this, because in Southeast Asia, we have a lot of rice producing, and rice straw is a potential substrate, sugar cane, and what not only the sugar cane, the leaves which cannot produce the sugar itself, corn leaves and something like that. And the third group is an industrial organic waste. I will talk about that later. Next slide, please. Yeah, now we look to the methods of pretreatment of raw material. Next slide, please. It's not always necessary to pretreat the substrate material to give it into a biogas plant, but in many cases it is very effective, and we distinguish between different groups of pretreatment. The first is crushing, grinding, milling. It's a kind of mechanical treatment, and there are crushing devices which can be connected to biogas plants, as you see in the picture in the middle down. And if you use, for example, cattle manure untreated and compare it after the treatment, you see on the right side, the material is more fine. You have a much higher surface, and this can improve the biogas formation process in a high amount, as we see in the next slide. In the diagram, you can see the specific biogas formation. It's expressed in volume per mass of organic dry mass, depending on the time. And you see the red curve shows the untreated material here in the example of horse manure. The biogas formation increases, but if you pretreat the material, you obtain the green curve, and you see that after about 10 days, you have a double amount of specific biogas formation. And in the end of this experiment, after 45 days, you see you have a much higher yield of biogas after this mechanical treatment. And the reason is there is a faster degradation of biomass. The result is that the gas is faster formatted, the gas yield is higher, and the degree of degradation of the material, the agility of the substrate increases, and the homogeneity, and you can steer much easier and save energy for running the biogas plant. Next slide, please. Yeah, on this side, you see a similar in the example of rice straw. And this is the methane yield depending on the particle size found by different authors. And you have about a factor of 2 between the higher particle size and the low particle size after the mechanical pretreatment of rice straw. Next slide, please. Yeah, there are different methods for chemical pretreatment, acid or alkaline pretreatment of the substrate material. And we distinguish in acid pretreatment between weak and strong acids. Usually sulfuric acid is used in higher temperatures, for example, in the temperature range of 160 to 200 degrees, several minutes. And in detail, substrate material containing lignocellulose is treated by acids or alkaline solutions too. And the reason and the goal of it is to remove the hemicellulose and to improve the first phase of biogas formation, the hydrolysis, and to improve the enzyme activity. On the other hand, the strong acid treatment is used for lignocelluloses too, and here the hydrolysis occurs by the acid and not by the enzymes of the microorganisms. In all of the chemical pretreatment, we must think about the corrosive properties of acids or bases, and we have to buy these chemicals, and we have to care about recycling. And it can occur that inhibitors or toxic substances can be formatted and hinder the fermentation process later. Next slide, please. Here you see in a scheme the effect of pretreatment in the case of rice straw. Rice straw contains cellulose, hemicellulose, lignin, and a structure which shall be destructed to improve the first step, the hydrolysis. And so we see the pretreatment can improve the hydrolysis process because the tertiary structure between lignin, hemicellulose, and cellulose is destructed. Next slide, please. Yeah, alkaline pretreatment is used to remove lignin too, and alkaline pretreatment destructs cell walls of the plants. The particles swell, the surface area is increased, so we have a higher hydrolysis and biodegradability, and can obtain increased methane yields about factor 2. We can use ammonia solutions for it, or calcium or sodium hydroxide solutions. There are different conditions to perform these pretreatments depending on the materials. In all cases, the solubility of lignin shall be increased solubility, or it's a first part of degradation which occurs in this treatment. But again, we have sometimes problem with the corrosive materials in the plants. Next slide, please. Yeah, there are other further chemical pretreatment. The literature is full with it. We can use hydrogen peroxide for not specific oxidation or mixture of soda and sodium sulfide, which leads to sulfonation of aromats and something like that, or organic solvents are in test too. Next slide, please. Yeah, the last group of pretreatment methods are biological methods, and the biological pretreatment methods can reduce the anaerobic digestion duration time and enhance the feedstock digestibility and increase the speed, the production rate. And the problem or the key of this pretreatment is to find microorganisms to do it, especially in detail, to degrade lignin for further fermentation. And a lot of fungal pretreatment methods have been tested. Very well known is to use white rot fungus or brown rot fungus or a combination of it to pretreat the material. And in literature, it could be observed that up to 50% in the case of rice straw, the methane yield could be increased. The advantages of the biological pretreatment methods is we have a very low energy demand, almost no costs for chemicals. It's much more eco-friendly, and we don't have to remove toxic substances as often necessary after chemical pretreatment. Next slide, please. Yeah, ensiling is another method. It's used in biogas technology. It's very well known from other agriculture process. We use lactobacillus to pretreat the material, and the production of lactic acid inhibit bad fermentation by bacteria, or the growth of some fungi, and some fungi can destruct the material which shall be converted to biogas and can produce in some cases mycotoxins. So we have pretreatment which is in many cases used to store the substrate material. In the beginning, I talked about we need continuous energy, and it's important to store the raw materials, and ensiling is one method to store the substrate for a longer time. And we tested this material in another project in Brazil, where a substrate energy cane was tested, and the results were quite well. Yeah, next slide, please. Now we look at parameters affecting the biogas formation. Next slide, please. Yeah, there is a lot different parameters we have to look at, which can influence the biogas formation and the fermentation process, the composition of the substrate, obviously the water content, temperature, kind of mixing effectivity of it. The pH value is very important. The retention time in the biogas plant, electrical conductivity, redox potential. It should be normally lower than -300 millivolt. In the next slide, I have listed some more. We can not all, on the next slide, please. Okay. Next slide, please. We cannot look at them all in the detail. It took a longer time, but very important is the pH value. It should be between 7 and 8, and the redox potential lower than minus 300 millivolt. So we have to exclude the oxygen, and we have to look at nutrients, main nutrients like nitrogen, phosphorus. We have to look at trace elements and the ratio of all these elements. And one of the main parameters is the so-called phostack. On the next slide, it's given in more detail. Can you, yeah, the phostack. I think persons who didn't deal with biogas don't know this parameter, but this is a very important parameter to control and to describe the biogas formation process in a biogas plant. It's a parameter who describes the ratio between the concentration of volatile fatty acids and the total inorganic carbon, which represents the buffering capacity in the biogas process. I said in the beginning, we have a process which can decrease the pH value, and the pH value should be between 7 and 8. And when the fatty acids are formed, then it can occur that the pH drops down and decreases, and this is usually connected with a reduced and decreasing biogas formation. And so it's very important to have carbonate in the substrate. And the phostack is determined by second step titration with sulfuric acid. The first step we titrate to pH 5, and in the second to pH 4.4. The needed volumes individually are multiplied with the empirical factor, and we calculate the ratio of it, and we obtain a number, a character, a number without dimension. And below you can see if it's between about 0.3 and 0.4, then the process is okay. And if it's higher, then it's overfed. We must reduce the substrate in continuous, the substrate load in the continuous running. And if we have lower than 0.2, we shall increase the feeding of the reactor. Next slide, please. Yeah, important for biogas development is to find new materials to use in biogas plants. Our goal is to find in detail waste material to convert it into energy and valuable materials. And so we have programs to test organic residue materials to find out, can it be used in biogas plants and which conditions can be used to use a specific material for it. Next slide, please. Yeah, this testing is performed in 3 different steps. The first step is a so-called batch test in a small amount. You see the apparatus on the left side. It's a standardized apparatus, and the residue material we intend to use is mixed with an inoculum, and we test the biogas formation for about 1 month or something like that, and calculate the biogas yield which can be produced from a specific material of this mass of the organic dry mass. I'll show you an example later. Next slide, please. The second step is a continuous test. We use for it 2-stage 10-liter fermenter systems. They are run in semi-continuous form, and we can examine how stable the process can run, the fermentation process. We can measure the gas amount, the gas quantity, its composition, the quality. We can observe inhibition and adaptation effects, and we can find out how to feed the reactors optimal, the space-time load, the composition and the amount of nutrients required, and the retention time. Next slide, please. On this slide, you see such two-stage fermenting system. It's a little older, but we use it up till now. The difference to the newer is, for example, that the feeding is from the not from the top, it's from the ground. And you see that we pump the substrate in the reactor number 1, and the overflow goes into the reactor 2, and the residue is stored in the number 7. The 2 reactors are steered, and we collect the formed gases in bags. You see on the left side in the photo is number 6, and we can use for further experiments with it and for determine and analyze the composition. There are other devices to analyze the specific gas components in the biogas too. Next slide, please. Yeah, the third step is the upscaling. And you see on this photo, on this slide, research reactor, it's about 1.5 cubic meter we have in our university to use the results of the 10-liter experiments and to upscale it to a bigger amount, a bigger volume, and to test all these parameters we have found out in the previous experiments and continuously measured is the gas composition, for example, like carbon dioxide, methane, hydrogen, nitrogen, oxygen, and other parameters can be measured too. And this it's important. This kind of reactor is transportable, and I will show you later. We can transport it to other places, for example, into factories, and connect it with other industrial plants. Next slide, please. Now we look at an example of our design of development and experiments to find out the new residue materials for biogas production. Next slide, please. The case study here I want to talk about is sludge of paper industry. We have in our region paper and tissue industry. I've read in Indonesia it's very important too. So maybe this result could be very interesting for Indonesia too. The problem is in paper and tissue industry, we have a lot of wastewater, and this wastewater contains paper and tissue fibers from the short fiber fraction, which cannot be recycled again. And actually, the water is dehydrated in 3 steps to obtain a higher amount of organic dry mass. And this process is very energy intense because the cellulose keeps the water very strongly. And after increasing the organic dry mass, this residue is combusted in waste incineration. And our project goal was to reduce the wastewater and to produce energy from the waste. Next slide, please. Yeah, here you see an example of the degradation of cellulose in the biogas formation process. Firstly, the crystalline cellulose decreased to single chain, and then in oligosaccharides After that, cellulose is formed, and the cellulose gives acetic acid and other fatty acid, and the final step leads us to methane and carbon dioxide. Next slide, please. Here you see the result of the first step of this study, the batch test. We used as reject this paper sludge with organic dry mass of about 5% at 38 degrees. And after about 5-6 days, we had the maximum of the specific biogas formation of about 500 liter per kilogram organic dry mass. So we have the potential of this material. Next slide, please. The second step was a little more complicated. The continuous fermenters have been driven for about 164 days. We have a startup phase. The reactor were fed with cattle manure, 1 liter per day, and then stepwise added the paper sludge. And after about 84 days, pure paper sludge was fed in the reactor, and we tested if this pure material can be used in the biogas reactor. And then we varied the feeding amount, the daily feeding amount, to find the optimum. Next slide, please. Yeah, here you see the specific biogas formation during this time. Can you click the one next? Can you click next? Yeah, the first is the startup. The startup with cattle manure, we have a specific biogas formation of about 300 liter. Then change to paper sludge, a little going up and down. It increased in the first period to over 500, but then after 28 days rapidly dropped down, and we found out it was a lack of nutrients and the pH decreasing. So we added sodium hydrogen carbonate and ammonia chloride and phosphate to add some nutrients. And in the period after 84 days to 164, the paper sludge amount daily fed was varied to find the optimum, and the optimum was about 600 milliliter per day in this reactor. Next slide, please. Yeah, here you see on the picture the material before and after the fermentation. The viscosity dramatically has changed, and this is obvious because the cellulose structure has been decreased during the process. Next slide, please. Next slide, please. In this diagram, you see the concentration of the volatile fatty acids and the total inorganic carbon. I talked about the phosphat, and this can show how it's that's important. We see that the concentration of the fatty acid about till day 42, it's constant, very low, and then suddenly increase. And in the same way, at the same time, the total ion carbon, the carbonate decreases, and the pH, as you see in the other diagram on the right below, decreased to pH 5.5. This is not okay, not good for the biogas formation, and it was necessary to add a basic substance like sodium hydrogen carbonate, and later we feed this compound daily, and we had to feed nutrients too, because the wastewater of paper industry almost contains no nutrients.
Prof. Albert, I'm sorry to interrupt, Prof.
Yeah.
You have 3 minutes left.
Okay.
Okay. Sorry.
Okay. Yeah, it's okay. It's fine. Next slide, please. Next slide. Okay. The specific biogas formation about between cattle manure and corn silage and the other parameters too. So we were very excited, and it was we were very satisfied with these results. Next slide, please. Here you see a picture of the process, the third scale, upscale, the transportable reactor connected in the factory. Next slide, please. After collecting all these data, we could calculate the biogas formation process for this waste material and can obtain from our results for a conventional fermenter, 1,500 cubic meter, very usual in Germany. You can convert 90 tons of paper sludge containing 4% of organic dry mass to about 860 cubic meter methane after cleanup. And this corresponds to the energy need of about 150 households for the conditions in Central Europe. To do this, we need some additives, as described before, sodium hydrogen carbonate and nutrients containing nitrogen and phosphorus in the amount given on the left side. Next slide, please. Conclusions, next slide, please. Yeah, production of biogas methane from residue can reduce fossil energy demand and environmental pollution, and fermentation residues are usual as valuable materials. Our goal is to use waste to produce energy and valuable other substances in the residue, and this can work in many cases. The production can be performed in central or decentral form or small and industrial scale plants. And it's important we can use this technique in industrial and in developing countries, and in detail developing countries where high temperatures, like in tropical countries, is interesting for the process. We don't need high-tech infrastructure, but we must test in laboratory before the materials, before doing it in the practical use. So we predict an increasing meaning of biogas technique for supply of climate neutral energy. Thank you very much for your attention. And I hope it was not too long. Oh, I was a little long.
Not at all. Thank you very much, Prof. Albert, for nice talks this afternoon. So actually, your talk and lecture triggered us to looking for the alternative energy. So I think there are a list of questions. So the first, I will give the chance for Alpes, Nicola Alpes, are you there? Okay, I think, hello, Alpes? Okay.
Yeah.
So, okay, I think Alpes not here. So I will read the question from Alpes, Prof. What are the contributions of biogases to the industry?
Shall I start the chat here? No. Okay. Can you?
Okay, so the first question from Alpes, what are the contributions of biogases to the industry?
Oh, what do you mean? In the energies of supply in Germany?
Actually, the question it's not so clear, but maybe it's related to your place, your country, maybe.
Yeah, in our country, biogas is increasing, and it was supported by the government for a longer time. The conditions sometimes changed. Sometimes it's a little more, sometimes a little lower. But now we have an election in this month, in September, and yesterday there was a discussion of the 3 persons who compete to become chancellor, and the the renewable energy are are very in a focus, and I think it will be increase in energy supply. If you drive through Germany, we have a lot of biogas plants which can be seen like on the photos. So many farmers use this technique to produce the methane, but in many cases the state has to support to start with it. But it's economically okay, good.
Okay, I see.
Yeah.
So it's mean that every place, every area have like a different kind of biogases development, right?
Yeah.
So the acceptable of the society about the biogases, it's different between another country.
Yeah. Yeah, we discussed about it, but it's more discussion about wind, the wind energy than the biogas, because wind we have the windmill everywhere in Germany. You can see it from far because they are very high, and there's more discussion about that than discussion about biogas.
Okay, I see. Okay, thank you very much, Prof. Albers. So another question from Ranum. Ranum, are you there?
Yes, here I am.
Okay.
Can
so
you hear
can,
my voice clearly?
Okay, of
Yeah,
course.
I can hear you.
You can ask directly to Prof. Albers.
Okay, thanks for the time. Pardon me, Professor. I'll asking you something. After the fermentation process, can we use the paper sludge for plant fertilizer or other? Thank you.
Yeah, this is a very good question, and actually there is another project to find exactly that. There are ordinances in Europe that usually you cannot use this sludge for as fertilizer or as fertilizer, because there can be substances inside which are toxic from the paper production process. But we are actually in a project to recover the valuable materials in the sludge. Different methods like precipitation of some elements or something like that. And so I hope it will be possible in the future to use this residual material too. Yeah.
Okay, it's clear, Ranum.
Yeah.
Yeah, that's all. That's very clear. Thanks for the time.
Okay.
Yeah.
Okay. Another question also, Prof. Albers from Lydia Martina. Is there any difference between the degradation of food waste and waste from animal?
Yes. I think always if you change the substrate composition, the biocenosis has to adapt, and you will find a different composition of microorganisms involved. We must confess that all the phases of the biodegradation process is performed by a community, and they must match together. And finding out how this process should be run, we always make analysis of the composition of bacteria and the other microorganisms inside. I did not present all these results, but in the investigation of paper sludge, for example, there were specific results which organisms are involved, and if you have food waste or waste from animal, there are differences too, but I have no results now in detail which is the exact difference. But there is always difference between if you use different substrate material.
Okay, thank you for your answer, Prof. In a Zoom meet, maybe in Zamam Ahmad, are you there? You raise your hand. Hello, in Zaman Ahmad. Okay, I think he's not there. So another question, maybe Aulia Amara, are you there?
Yes, I am.
Okay. So you can ask direct to Prof. Elbers.
Okay. Is it common in Germany for use biogas in industry and general public?
Yes.
Okay.
Yes. Yes.
It's really common, right?
Yeah, it's usual, and I think it will increase now. After this paper, actually, we have a project with paper sludge from other plants and other factories too, to find out where are the differences, and to find out in which case it's economically useful to do it. This is a calculation you must do, the conditions, the costs, the additional costs, and the economically result is very important if it's used or not. And in many cases, it's economically, and it depends on the conditions made from politics, if it's economic or not.
Okay. Thank you. So Aulia Amara, I think it's clear, right?
Yeah.
Yes. Thank you for your answer.
Okay. So maybe another question from a student, Don Amando from Timor-Leste. Are you there?
Yes, I'm here.
Okay, so you can directly ask your question, right?
Okay, so my first question is about the part of the animal feces is making biogas, and also your human body feces can make a biogas. And second is there some of the case where
Don Amando, maybe you can slower your voice.
I've read it.
Sorry.
Okay.
The first question is, apart from the animal feces that make biogas, and also human feces can make a biogas. And the second is, there is some case they use a biogas from the cooking, and as the gas using for the cooking that's not causing environmental problem, or the steaming can transform this dioxide carbon that can give a negative impact for our environment. So and the last one is, can biogas be sure to replace fossil fuel? And we all know that most of the people still use the fossil fuel.
Yeah, they're very fundamental questions. Of course, human feces could be used. I think it's more a technical program, and you have to think about hygienic aspects and logistic aspects to do it. For example, for big cities, it's not so easy. I think it's more a logistic problem than a scientific problem. I think the material could be used maybe in co-digestion. There's some case where biogas can be used for cooking. Yes, it's in a small scale. It's possible. You can store it more, for example, in tires or something like that. For cooking, do not call it. Yes, you're right. After burning the methane, you get carbon dioxide. That's correct. And then you have a climate relevant gas too. But the important difference is you use it as energy source before, and it's renewable energy. It's similar like if you burn plant material, you produce carbon dioxide too. But before, this carbon dioxide have been stored by photosynthesis into the plants. So you are in this cycle. And this, I think, is similar for the biogas process. Yeah, you can burn it. And the big advantage is, before, you can store the energy because you can store the methane, and you can store the substrate material. And the third question, can biogas be sure to replace? Yeah, it can replace a part of fossil fuels. We can use it in cars, and we can use it to heat our households, and it can replace a part of it. And the advantage is we can produce it from not fossil sources. So it's climate neutral. It can be driven climate neutral. Is that what you mean?
Hello, Don.
Yeah. Next
Don,
question, please.
Okay.
Yeah.
Maybe Don Amado, it's clear, right? For the answer from Prof. Albert. So, Ahmad, you raise your hand. So, can you open your mic so you can ask directly to Prof. Albert?
Okay, yes. Am I audible?
Yeah, hello.
Yes, sir. Sir, my question is in future, which will dominate battery operated vehicle or biofuel operated vehicle? Because these days race are going on.
I didn't understand.
Okay. I will repeat. Which will dominate in the future? Boil fuel operated vehicle or battery power automobile?
Yes.
Yeah, I'm a little skeptical with the electrical development because the high weight of the batteries needs a lot of energy to speed up, and we need a lot of materials in the battery which must be produced with environmental damage. You need some elements, and in some places in the world you can see what it means to produce this material to produce the batteries. So I think we should go into other directions. We could more look into hydrogen technology and something like that. This is not the only way to solve the problem, but it's one part to save fossil energy and to use waste material. So let's think about converting waste to energy and valuable material. I didn't talk about the other valuable materials which can exist in the residues of the fermentation. We can convert it into some organic substances, polyphenols. We can convert to bioplastics. And in some cases, it was found out that some plants enrich rare earth elements and something like that. So the residues are valuable in some cases too. Fertilizers, of course, too. So I think it can only be a part of the problem, but we should look at every possibility. We can do something here.
Okay. Incredible, Prof. Albert. So, okay. How Ahmad? Okay, Ahmad, I think clear with your answer.
Yeah, some more thing. Yes, can I?
I'm sorry, it's not clear, Ahmad, what you want to say?
Yes, I would like to ask some more questions related to this. One more.
Okay. But I think 1 to 2 minutes, okay? Because the time is limit. Okay, Ahmad.
Okay.
That's good.
Shall I?
Okay.
Yeah, of course.
Yes. Yeah, I'm asking that because these days battery power has taken a big intention of people around the globe, and but no one is going to focus on biofuel, and
yeah,
these are very, you can say, very less developed area. And which country is going to develop more on biofuel? Do you have any idea?
Which country?
Yeah.
I didn't completely. There wasn't.
Ahmad, maybe you can repeat your question slowly.
Okay. Yeah, I'm asking. Yeah, these days battery has taken a great intention of people around the globe, and all are going to focus on battery energy only, and no one is going to on biofuels. And my one question is, which country is more developed in produce the energy from?
So maybe his question about which country that develop biofuel,
yeah,
that intends develop.
Yes,
Yeah, I don't know which other countries are developing here new techniques. I think we do a part of it, and here in our city we have a research center and a new technology center to it's called Brainergy Park. We found in our small city to develop more such kinds of energy for use. And I think the hydrogen technology now here in our region is pushed very much. And a lot of money for research and development is
okay,
put
thank
into this.
Okay. Okay.
But I
Okay.
don't know if America is more. Yeah.
Okay. Okay.
Maybe after Trump it will be more. Yeah, I hope so.
Okay, thank you, Prof. Albert, for your answer. I think Ahmad, it's clear, right? So, Prof. Albert, actually, it's really incredible lecture. So, and I do believe the students still have many questions to you. Maybe I will recommend to Dr. Husni. Maybe for the next science camp, they have to make a longer sessions for discussion.
Fine,
Okay,
yes.
because it's kind of our program is time's up. So maybe I please you to make conclusion remarks to close your talk, Prof. Albers.
Yeah, my conclusions I've wrote on the last sheet. I'm a chemist and a long time busy with ecological chemistry and ecological problems. But I think a main focus must be very near in the future to change to more climate friendly energy and to reduce the energy demand worldwide. And I think in detail, the Western countries have a high responsibility to do it because the Western countries mostly have the highest emission of climate of gases who affect the climate. So we must develop new techniques to reduce it and to bring it to all countries. And I think something like biogas can be a very good export because it can be handled quite comparable easy under conditions of developing countries.
Okay. Thank you very much, Prof. Albers, for your incredible and insightful talks for this afternoon. So once again, I thanks very much for giving us such a lecture. So I ask the participant to give big applause for the Prof. Albers. Okay. So once again, thank you very much. So now I will give it back the control of the agenda to the Miss MC, Miss Nimel. It's time for yours. Thank you.
Thank you very much.
Thank you so much, Mr. Vira, for driving the lecture, and thank you also for Professor Jiren Alpers. Ladies and gentlemen, this is the last lecture of today's event. I hope today's insightful lecture will be one of our footholds in achieving more knowledge in the future. But before we close this event, let us give our big hands for the closing by the head of Office of International Affairs FMIPA UM, Mr. Husni Wahyu Wijaya, PhD. For Dr. Husni, the stage is yours.
Okay, thank you very much. Thank you for this great event in the Science Camp International Virtual Lecture. To all students, thank you very much for the time to join in our occasion, Science Camp International Virtual Lecture 2021. And we are glad that the students from Indonesia, Malaysia, Thailand, India, Cambodia, Taiwan, Pakistan, Uganda, Philippines, Timor-Leste, and Bangladesh are highly interested in this event. Our hope that every nation will cope this pandemic, so you can come to Indonesia and Indonesian student can go abroad to seek his experience, his dreams, his challenge, and his passions. Thanks to all lecturers in Science Camp FMIPAU 2021. The first is Dr. Renat Ubed Sonai from Department of Chemistry, Universitas Negeri Malang. Dr. Suharti from Department of Chemistry, Universitas Negeri Malang. Agung Wicoro and his students from Department of Biology, Universitas Negeri Malang. Dr. Vivi Novianti from Department of Biology, Universitas Negeri Malang. And special thanks to Dr. Geren Elberts from Aachen University of Applied Science, German. And please, I will share a screen first. Okay. 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 And as so in your screen that we invite all students who are joined in science camp international lecture to join in our international lecture tomorrow, Equalis, and for our students who are joined in this event are free to attend as attendees in this event. Just rename your Zoom account with the science camp underscore your name, and then join with the Zoom meeting as so in the screen, and then our committee will let you join, and after you follow all international conference, you will get what is certificate as attendees. Normally you have to pay around $50, but because you are joined in our international science camp, you are free to join. And also we have a seminar national conference in Indonesia, I think only. So you can also join in our location on 25 September. And then we have from Japan, from ICE. So you can join. This is also free. Particularly if you are from Indonesian student, you can join as a participant or a presenter. Okay, thank you very much for your attendees in our occasion. See you in the next Science Camp to 2022. Okay, thank you very much.
Thank you so much, Dr. Husni. And ladies and gentlemen, before we end this meeting, I'd like to invite you all for a group photo. Hence, please kindly enable your video or turn on your camera so that the committee could capture your beautiful smiles. So yeah, I hope everyone is ready. On my count, in 3, 2, 1. Once more, ladies and gentlemen, 3, 2, 1. Very well. And finally, we come to the end of today's agenda. On behalf of the OEA FMIPAT teams, I would like to express my appreciation to all the participants for taking time out of their busy duties to attend this lecture. And I'd like to remind to all of today's participants to fill the attendance form, which the link is provided in the chat box. So that's all from us. Thank you for the participation, and we ask to apologize to you for being mistaken. And the last I say, wassalamualaikum warahmatullahi wabarakatuh. See you on the next event.
Waalaikumsalam warahmatullahi wabarakatuh. See you. Thank you, Prof. Elbers and everyone. please.